Welcome again. In this lecture, we are going to discuss noise, missing values, and outliers in detail. In particular, we will be interested in defining what a missing value is, what a noise value is, and what to consider an outlier. Now, in case of missing value, it's quite obvious that the value of that particular cell is not given. That is, a record or an instance do not have a value for one of its features. In case of noise values, we have a value for an attribute for a given record or instance. However, that value is very much different from the rest of the values of that particular column or feature. Noise values can also be considered outliers because they outlie the general pattern of that feature. However, the term outlier is more frequently used for an instance or record that has got one or more noisy values. Outliers or noise values can also be called anomalies. So what actually they are? These are the values that does not comply with the rest of the values. That is, having a general pattern shown by most of the values of a particular feature, anomalies or outliers do not fall into that particular pattern. They are much different from the rest, which makes them doubtful to be legitimate. If we consider a large dataset, a good number of data elements, say 98% of the data for any column is going to conform to a general pattern or a particular set of values for that matter. The remaining 1 or 2% of the elements or attribute values are likely to be candidate for errors or noise and are therefore considered outliers. To uncover an outlier in the data, it is very much important in the first part to define what normality is in the data. At the pre-processing, as we said, we are particularly interested in handling missing values, noise values, and outliers. The process can be a two-step mechanism where we need to identify the cells with these problems and then handle them accordingly. So it's a two-step process where these issues are to be detected in the first part, and then having them detected, we need to come up with a mechanism that would handle them smoothly. Now, detection of missing values is a very clear-cut process. We can see that such cells do not have any values provided, like we do not have any value provided for record with ID 1 for its payment. Missing values can be represented with a question mark, an asterisk, a name, or just an empty cell. Over here, we do not have city provided for the item with ID 7. In comparison to missing values, identifying outliers for an attribute or a cell is not that straightforward. In order to identify and uncover outliers in a data, it is very much important to identify the trend of normality in the data. For example, if we look at this column, normality is going to say that the value should be somewhere from 2 to 6. Now this value that is very much different from the rest indicates that this value is most probably a noise value. Therefore, in order to define outliers, we first need to define what normality is for any given feature. We have to understand that in some cases, a very different value can still be a legitimate value depending upon the attribute, and that can only be understood if there is a domain expert available. However, in absence of such, we may not trust values that are different from the normal trend. That is, conforming to the normality represented by the rest of the values for that attribute. A dataset generally has different types of values, and depending upon the nature of that attribute, the detection and handling of that missing or noise values is dealt with accordingly. Now, if we look into this column of city, we have names of different cities. This is a categorical data, and we have to think about it, that how we are going to make use of it for training our model, or in the first place, how to make use of these values to detect this missing value. Different techniques can be used for this purpose. Another consideration is that this categorical data does not have any order in it. For example, we cannot say that Colombo is less than Singapore or Tokyo is greater than Melbourne. So this is a categorical data and that is unordered. If we look at this attribute that is representing items, this attribute has a numeric value that is an integer. And generally the values are smaller, that is less than 10, and we do not see any value that is in negative. So this shows the general trend of values for this particular column, and this information is going to be very much helpful in detecting this noise value and coming up with a better value with which we are going to handle this problem. Considering the next attribute that is having price, we can see that the values are generally in hundreds and thousands. However, this value again is most probably a noise value. Maybe the user has mistyped the text value for something over here because the value is very much close to the values of this column. Whatever the case may be, this value is most probably an erroneous or incorrect value by looking into the rest of the values of this column. The next column is payment. For payment, we can see that the values are zeros and ones. Now this is a binary attribute where 0 means that the payment is not being made, while 1 means that payment is being made. Again, in order to identify this missing value, the nature of this attribute is going to play a role. Next we have taxes, and the taxes are small values that are floating point numeric values. We can generally see the trend that the values are around 1 or less than 1 and are all positive values. Finally, the last column represents the labels for these instances, where we have yes for a transaction completed while no for a transaction that is rejected. These columns are called attributes, features, or characteristics that represent the nature of any given instances or records. Each row is called an instance, an object, or a record. So we have 7 records in this dataset. Each record has got 4 features, excluding this ID that does not mean anything related to the nature of the data, and thus the last column represents the labels of these instances. So in this lecture, we looked at a dummy dataset where we tried to identify the missing values and the noise values. And we said the process has to be a 2-step process, where first we have to detect a missing value or a noise value and then handle it according to the rest of the values of that particular feature. And I'll reiterate an important point, and that is, in order to detect something to be abnormal or anomalous, we first need to define what we mean by normal. So before declaring a value to be a noise value or anomalous value, we need to define normality for any given feature. So with this, we conclude this lecture and we'll continue from here in the next one.